You, me, the TV you're watching, and our home planet, the Earth, are all pulling on each other. That's gravity. And where I'm standing, this is down.
Thank you for recycling.
Everything, every piece of matter in the universe has gravity. And gravity always pulls. So big and massive is the Earth that it pulls on everything. It even holds the oceans on the Earth's surface. It pulls on the air we breathe. The pull is always toward the center of the planet. So no matter where you are on the Earth's surface, down is this way. Take a look at this. It's the gravitational tower of science. Up at the top, we have a bowling ball, about 7 kilograms, and an apple, about 100th of that. When I pull this cord, a trapdoor will spring open, and the apple and the bowling ball will go hurtling toward the center of the Earth. What do you think will happen? Well, you might think that since the bowling ball is heavier, it'll fall faster and land first. Don't bet on it. You ready? 3.
Potato.
2.
Potato.
1.
Potato.
You want to see it again on the instant replay close-up camera of science?
Uh-huh.
Potato. 2. Potato. 1. Potato.
See, they hit the ground at the same time. Now, this is a famous experiment. The first guy to do this was Galileo Galilei in Pisa, Italy. He did experiments with cannonballs of unequal weight. And the story goes that he took the cannonballs to the top of the Leaning Tower of Pisa, let go of them at the same time, and the townspeople were amazed when they saw them hit the ground at the same moment.
Well, in my left hand I have a feather. In my right hand a hammer. And I guess one of the reasons we got here today was because of a gentleman named Galileo a long time ago who made a rather significant discovery about falling objects in gravity fields. And I'll drop the 2 of them here and hopefully they'll hit the ground at the same time. How about that?
You gotta realize that the pull of gravity affects everything. Without gravity, there'd be no you. There'd be no me. There'd be no Earth. There'd be no sky. Gravity, now playing everywhere.
Now, in amazing Attractovision, just try to escape the big pull of gravity.
What is it?
It just keeps pulling me and pulling me and pulling me down. I can't escape it.
What does?
Gravity!
Feel the pull of gravity. This film has been rated G.
The pull of gravity extends over huge distances. Now, let's say this beach ball is the sun, 330,000 times the mass of the Earth. And the attraction of gravity between the Earth and the sun is so strong that it can keep the Earth in orbit even when it's way out here, 150,000 kilometers away. Gravity holds all the planets in orbit. It also keeps the string on this inexpensively produced model of science tight. When you step on an ordinary bathroom scale to weigh yourself, the Earth's gravity pulls us down. But there's a scale in the way, so the scale gets squeezed. Now, the more we weigh, the more the scale gets squeezed. And that number we call weight. So weight comes from our mass, the Earth's mass, and gravity. So powerful is the Earth's gravity that it even holds the ocean on the Earth's surface. Now, you know that when you're standing on the Earth, you have weight. That's because you and the Earth are both made of matter, so you both have gravity and you're attracted to each other. So on the Earth, I weigh a little over 70 kilograms. That's about 155 pounds for you grown-ups. Now, suppose you could stand on another planet, somewhere else in the solar system. So you'd have weight there too, because those planets have a lot of matter, and they have gravity also. Let's say you were standing on the biggest planet in the solar system. Let's say you were standing on...
Incomplete.
Now let's say you were on the biggest planet in the solar system. That would be Jupiter. Jupiter is much, much bigger than the Earth, so it has much, much more gravity. On Jupiter, I'd weigh, over 180 kilograms. 180 kilograms. I mean, that's so much gravity, it'd probably be hard to stand up. It would pull you down like one of those push-up string puppets. Let's say you could stand on the moon. Now, the moon is much smaller than the Earth, right? So it doesn't have nearly as much matter. So it doesn't have nearly as much gravity. So let's say we could stand on the moon. Oh, gee whiz, I'd weigh only like 12 kilograms. 12 kilograms, that's nothing. I mean, I'd be bouncing around like an astronaut.
Hippity hoppity, hippity hoppity, hippity hopping over a hill.